Hello everyone, classmates and also to Ma'am Aljen. So, akong napili nga topic is city scale producing our traffic routing by sampling max flow using MCMC. So, what is MCMC? MCMC is Markov chain Monte Carlo. So, it uses multiple diverse max flow solutions. So, mo na siya si MCMC. Then, by using this traffic simulator, it prevent the air pollution. So, kani siya nga traffic simulator kay place a big kuan
Plays a
uh,
big factor in
big
making
factor in making the air pollution. So, that's why nag-compare sila sa later on I discuss it. So, next is introduction. Breathing dirty air pollution a long time can affect people health. So, Pope the Third and the Curry 2006, according to the World Health Organization (WHO) in 2016, 91% of people worldwide live in places where the air is dirtier than what's considered safe. And this kind of pollution outdoors leads to about 4.2 million deaths every year. So mostly because of stroke, heart disease, lung cancer, and ongoing breathing problems. Places with poor money often face the worst effects, especially in the Western Pacific and Southeast Asia regions. So road traffic in cities play a big part in making the pollution. So ang atong objective sa niya is first one is avoiding extreme pollution in any area. The second one is enabling short transit times, and then the last one is making effective use of the road capacities. So sa atong ang significance of the study is we build upon this line of work to develop a significantly faster solution for solution aware traffic routing using a Markov chain Carlo. So atong ginoy sa introduction. And then base method to sample integer max flow solutions from a planar graph and generate a key optimal set of max flow solutions. So our research gap is, however, existing work in this space can only be used for a small areas due to computational scalability issues. So klaro kay no nga dili gyud siya kakuan og dako nga area. And then as we can see here, our methodology is the pollution release, the figure 1, pollution release on road lengths for traffic simulations on a large area of Seattle, USA. Color legend given at bottom is the percentage of the max pollution left obtained using only a single flow FFA. So kani nga left kani siya dire. And then gamitan check FFA, and right is using our max flow MCMC. So asang gani ha. Then which uses multiple diverse max flow solutions. As can be seen, server pollution red, purple, black is prevented. So kani si MCMC is ang yang use is multiple diverse max solutions. So multiple siya yung diverse max solution. Unlike sa FFA is using only a single flow. So na yung siya dakong kalahian sa FFA o sa max flow. Okay, by using max flow, ma-prevent na to ang air pollution by using this what we call using this traffic simulator, the MCMC. Next, figure 2, 7 diverse max flow samples from the max flow MCMC algorithm. Traffic is routed according to this and simulated in sumo for equal intervals, resulting in the emission heat map. So mo na siya ang 7 diverse max flow samples from the max flow MCMC. So as we can see here, the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, and then the last seventh kapito. So let's proceed. Wait, nasa man? So they design a Markov chain that can be used to sample integer max flow solutions from a planar graph with probabilities proportional to an exponential of the length of the solutions. So sampling integer max flow using MCMC. So they consider the root network to be a planar graph G. Quantity of V and A, edges E of the graph will be the roots, while nodes V will be the junctions where roots intersect or represent the end of the roots. Each root in the network has a length and a specific number of lanes used as the edges capacity, since one vehicle can travel through each lane at a particular time. Let S be the source node from which the vehicle travel to the destination node T. We want to ensure that the maximum number of vehicles can travel from S to T at any time, and hence represent this as a maximum flow problem. So, okay, no? And then as we can see here in figure 3, this is the example of the transition in the Markov chain. The underlying road network has 16 junctions, forming a grid with max from a value from 1 to 16 to be 2. So, kaning 1, 2, 3, 4, 5, tama sa 16, more siya 16 junctions. So, the state space consists of all max flows from 1 to 16. So, kaning mga araw-araw niya, 1 to, tama sa 16. Muna siya ang state space consists of all max flows, which can also be considered as a pair of 1 to 16 paths. So klaro kayo ano din using arrows. The transition in M-flow given in algorithm 1 involves choosing one of the paths P in red and one faces F1 to F10. So F1 dara taman siya ni F10. Dire 9 ang 10 ani niya is of the planar random and rerouting the path along the face. The face F1 and F9 are the mark in the graph. Arang F10. And F10 is the outer face. So, ang F10 niya is the outer face niya. Let's proceed. Set of MF number of paths. It is the maximum flow value from S to T. We define a Markov chain M flow whose state space theta is omega is the set of all integer max flow solutions. We define the total length of a max flow solution X. Denote X as the sum of the lengths of all paths in it. The length of each path will be the sum of the lengths of all edges in the path. We can write a path of the max flow solution using face if they have one more common edges as shown in figure 3. So this is the algorithm. M-flow X defines a step of the Markov chain on the current state. Siya. And then convergence of the Markov chain. We show that the Markov chain M-flow converges to a stationary distribution which has a property that the probability of max flow X will be proportional to setting. So first we show that the distribution with the above property is a stationary distribution. So the lemma 1 is stationary distribution of M-flow is this one where kanisha. Then the proof uses standard arguments and is provided is appendix. And then they use the MCMC method to obtain a set of diverse max flows key optimal, and use it to give the first approach to designing a large scale transport policy that avoid severe pollution while maintaining reasonable transit times. Traffic routing using such a set of max flow ensures that a diverse set of paths are used which prevents concentration of pollution. Vehicles are routed through shorter paths and capacity of the road network is fully utilized as it is a max flow. So, mas makakuan yun ang max flow. And then we propose to use the max flow MCMC algorithm to generate a key optimal max flow solution set, which can be used for routing vehicles in such a way that the pollution is evenly spread out even through our chain is not rapidly mixing. We can start sampling before the chain has completely mixed as we do not need the solutions to follow the specific distributions for our use case since we are just sampling to generate a key optimal set of max flow solutions. So we define the key optimally of our solution set similar to the definition of key similarity in Barrett et al. 2008. A set of max flow solution is key optimal when any two solutions from the set have most key common edges. So there are multiple ways by which max flow's MCMC algorithm can be implemented in real-world scenarios. So, as described in Kamishiti, Vadlamanati, and Paruchuri 2020, traffic police can use different solutions to route the traffic on different days. For example, by identifying a set of 7 solutions, traffic can be routed using one solution per day of the week. So, a solution can be implemented by restricting the set of paths available for a vehicle to take and the number of vehicles on each path, but does not restrict a vehicle's choice among the allowed ones. GPS software like Google Maps can use the suggest different set of paths to different users on different days. Autonomous cars can be routed using our method, where vehicles can be instructed to use different paths. The simulation of urban mobility, SUMO, is an open source, microscopic, and continuous traffic simulation package designed to handle large networks. SUMO comes with a large set of tools for scenario creation and simulation and can handle multiple aspects of traffic flow generations, including computations of acceleration, deceleration, emission modeling, congestion, the distance between vehicles, and etc., resulting in realistic modeling. So with this, our max flow or MCMC traffic policies using the SUMO traffic simulator on real-world maps. The performance was compared with key PMFA and FFA algorithms. They also demonstrate the scalability of max flow MCMC on large real-world road maps. So the result, they benchmark the performance of their max flow MCMC based traffic policy on a large-scale maps of many cities along with baseline algorithms. They also compare it with previous work of key PMFA, Kamishiti, Vadlamanati, and Paruchuri 2020 on a small map due to its scalability issues. All the network were obtained from OpenStreetMap, Hackley and Weber 2008. So, as you can see in figure 4, max flow, top, and pollution bottom generate for different policies of the Mach of settle with 2 T pairs. MCMC denotes routing using key samples from Markov chain. Max flow MCMC with 7 samples prevents severe pollution, red, orange, from happening in any area. Legend of colors is same as figure 1. So using the FFA, this is a FFA, the MCMC, and then the MCMC. So nagid akong kalayan diferensya nila sa ato makita diri. Nagid akong kalayan sa FFA and the MCMC. So conclusion, they design a Markov chain to sample integer max flow solutions for a planar graph. They use it to build an urban traffic routing policy that prevents the concentration of pollution. Since MCMC algorithms are very efficient, we are able to scale our experiments to large cities. We believe that the sampling of method for integer max flow can be of independent interest in solving other combinatorial optimization problems. For future work, the policy can be expanded to non-planar graphs since real-world maps can contain flyovers and traffic between multiple sources and destinations. So that's the end of my topic. Thank you.